and then there's just no inner r. There's no little r, basically. All right, so Noel, you wanted to see number 3 and say why is that not shells? Just looking at it, my hunch is that we probably could do shells, but let's see. So number 3,
We did something similar to that.
yeah. So we got y equals x plus 6. So 1, 2, 3, 4, 5, 6. And y equals negative a half x. And x equals 1. And then about y equals negative 1. So y equals negative 1 is down here. And then y equals negative 1 half x. Yeah, this one is not a nice graph to look at on the page. Sorry about that. So there's your negative 1 half x graph, x plus 6. Oh. And x equals 1. So these intersect somewhere back here. So then here's our region, this triangle. And we're rotating it about this horizontal line y equals negative 1. I would be inclined to do washers, because washers means we're orienting ourselves vertically, and then the top part is always this line x plus 6, and the bottom part is always this other line negative 1 half x. So I think washers will be easier. If we do shells, right minus left is going to be tough for the top minus bottom, because right minus left depends on how high you are in that region. So when you're down here in the lower part of this region, right minus left is 1 minus the lower line, so negative 1 half x.
So would there be 2 intervals?
And there would have to be then 2 intervals. We're up here, so that would be your height in this situation. And then your height up here would be 1 minus x plus 6. And then you have to figure out where this is. So you already have to find out where each of these lines intersect 1 and where they intersect each other in order to do shells. You'd have to find that out again and then break this up into 2 integrals. So if we're doing shells, these 2 lines intersect each other. X plus 6 equals negative 1 half x. So that would be 3 halves x equals negative 6. So x equals negative 4. So this is a negative 4 back here. And then this is at 1. So we'd be integrating. Right, if we're doing shells, you got to find the y. Oh, okay, this is a pain. So if we're doing shells, Noel, then we got to do things in terms of y. So this would actually be negative 2y. And this would be y minus 6. And then we have to find in terms of, so could you do shells? Yes. It's a super pain in the ass. Washes is a lot easier for a variety of reasons.
Is there ever a time when you cannot do shells, like even with a calculator, or just for washers? Or is it like you can always do it?
There's definitely times where you cannot do shells, even with, you cannot do washers, even with a calculator. And that was like the example that we used to introduce shells. So if you remember this example where it was like this curve, and we wanted to rotate that about this axis, and this equation is something like y equals like x cubed minus x squared. This cannot be done with y, because you cannot get x by itself. In order to do washers, you have to orient this perpendicular to the axis of rotation, the y-axis here. And then the outer R and the inner R are based on the same curve, and getting that curve in terms of y is not going to happen. It's not just that it's messy, it's that it won't. So this is a situation where you have to shells. Are there situations where shells will not work? My hunch is yes. So Bethlehem, to answer your other question, I'm assuming there are probably situations where shells just won't. But that's harder for me to come up with on the fly as well. Here is an example of shells will work, but it's really no fun. Because you have two different integrals, you have to get both equations in terms of y, you got to find where they intersect in terms of y, and you got to find out this y value and that y value, and then it's a mess. Washers is a single integral going from -4 to, you already know this is 1 for x, and the top minus bottom doesn't change partway through the integral the same way right minus left is going to change halfway up the graph. So shells, I mean, yeah, it would work, but it would be awful. But that doesn't mean that there aren't other situations where shells just really won't work no matter what. Any other questions with the homework? On the whole, how'd it go? Pretty good? All right, cool. This came from a guy in my church who had gone to China, and he brought back some ties. So he gave ties to people who are in the church who happen to be teachers who have a reason to wear ties on a regular basis. So Alex has a similar tie that's, I think, more blue.
For Twin Day.
Yeah, guess who doesn't talk to each other about what they're wearing?
Should.
All right. 1, 1, 4, 5, 5. So rows 2, 3, and 6.
That's the first time we go.
Why? What's wrong?
I did it all backwards.
Whatever. So I said, how'd it go? He said, it went okay. I mean, I got them all wrong.
I mean,
It was
I
okay.
know what I did wrong.
Oh, okay, well, that's good. Yeah, I'm not grading it for
I know,
all
but
right.
it's just
I'm
like
grading
how
it
do
for
you
did you do
mess
it all in my
up
direction?
big one?
So what was it, 2, 3, 6? So Brianna, Diana, Diane, Kirsten, please also, thank you. Submit your work for this. 2, 3, 6. And then,
Whoa.
you got whiteboards. So, going back to areas.
I lost my worksheet.
Oh, that's fine. Thank you. Ugh, I'm just going to present this in the chat. Present window. Present that thing. All right, so if you're in the chat, here is the what I'm looking at, and we're going to do whiteboards. So we're just at this point reviewing everything from Chapter 7. Everything from Chapter 7 is areas, volumes using washers and discs, volumes using cross sections, and volumes using shells.
Sorry to interruption. Can I have Skip Barnes go to room 114? Skip Barnes to room 114. Thank you.
So if you have your packet, it might be easier for you to see this directly from the packet. But if you're not, just look up here. And go ahead and do this on the whiteboards. In this situation, you're just setting up the integral and selecting which option. And keep in mind, we're only looking at the first quadrant of this thing. That on your whiteboards. Or E, yeah. So, you know, square root looks like this. It's the parent function. This is like root x. Root x minus 2. The minus 2 is inside. It takes this and moves it right 2 spaces.
You can also think,
Wait, what?
so square root of x minus 2. That's a shift to the right 2 spaces.
So it looks
So it looks like this, but starting over here. So that shift just moves your starting point.
you said he's gonna use the like that perfect graphic.
Nope. So you said. Because we want to integrate, we're doing stuff in terms of y, so we want to go up the y-axis, not across the x-axis. Yes.
What we change to what?
Nope. So what's the distractor for that answer? You just have your right minus left backwards.
Oh.
You are thinking of integrating across the x-axis, but we're doing stuff in terms of y. You want to go up the y-axis. There you go.
Change the jump to the end.
That's not one of the options, though.
Right.
So look at your options on a multiple choice test. You got to choose from among the options given. Good. How many digits of pi do you know?
Oh, like over 100.
Holy crap.
Yeah.
You're wrong. So you are forgetting that we're only in the first quadrant, Sam. Now you're forgetting that we're in the first quadrant only. So you don't want to go all the way down. You only want to look at the top half of the graph.
It's not. Oh wait, no, that's
Yeah.
it's not.
No. Because now you're still doing the boundary integration. There you go. All right. So y is a. By the way, the answer is a. So y is a. If we graph this thing, and first of all, notice, hey, you see how everything's in terms of y? That's tipping you off. We should do things in terms of y. Hey, look, we're already in terms of y. Let's just leave it alone. So how do we then graph this? Say you plug in 0 for y, you get back 2 for x. So you have the point 2 comma 0. Then plug in 1 for y. 1 for y gives you 3 for x. So you're kind of graphing backwards from what you normally do. You're plugging in a number for y and getting back a number for x. So you plug in 1 for y and get back a 3 for x. And so on, and then it's going to look like this. That is a parabola. Normally the parabola would do one of these things, but we only care about the first quadrant, so delete that. Erase that, whatever the word is. And we're only taking this out until x equals 4. So x equals 4, cut that off, because that's the other line enclosing this region. So now we have this region, and since we're just finding the area in terms of y, here's a rectangle. As we're doing things in terms of y, we got to be perpendicular to the y-axis. So right minus left is going to be 4 minus the curve, and the curve in terms of y is y squared plus 2. Put that whole thing in an integral, and now we're integrating in terms of y, so we want to go up the y-axis, not across the x-axis. So we're starting at 0, and then going up to wherever this hits 4. And if you just set this thing equal to 4, you find out that that's going to be root 2 for your upper bound. Ta-da! So that's A. Any comments to follow that up? All right. Let's do another one. Number 2. So which of these?
C.
Good for you. No. So which of those gives the area between x squared and negative x on the interval from 0 to 3? So here you're actually finding out what the area is. squared minus negative x. Right, so top minus bottom. If the bottom is negative x, you're subtracting negative. Yes. 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 Yes.
We do a bonus problem?
Yeah.
I feel like we haven't had a bonus problem.
Good.
That was that last.
Should be positive. Area.
Yeah, that was last semester.
You bottom minus top. So from 0 to 3 is over here. You get negative x minus x squared. It should be x squared minus negative x. No, it's over here. 0 to 3. Yes. All right. So if you graph this, y equals x squared is one of these things. Negative x is one of those things. And we're going from 0 to 3 along the x-axis. So it's this region right here. And so top curve is x squared, bottom curve is negative x. So area is top minus bottom. Be careful when you subtract a negative. That's really just going to become x squared plus x from 0 to 3. And if you set that up right, integral of x squared plus x from 0 to 3 turns out to be 27 halves. So that was E. Next one. This one. Use your calculator to come up with the answer. If you can show the correct integral that you're going to use, that's good. And then if you can put that in your calculator and evaluate it with your calculator, that's going to be what you need to do. And that's e to the negative x squared. Yeah. So one curve is y equals e to the negative x squared. The other one is y equals negative sine of 3x. Also, you can see, that's not going to help you, Michaela, as that doesn't do integration. Borrow mine. And then I'll try to make sure I have calculators for you guys on test days, for those of you who don't have your own graphing calculator. No, it's not 1. Yeah, they don't intersect at x equals 1. They intersect at, here's 1, and here's where they intersect, a little bit past 1. So you need to also find the intersection point. And that's also something you got to do with the calculator. That's not, I mean, that's what you would do algebraically.
This is what we're talking about, right? That's really almost it out.
No, that's for logs, not for exponentials.
So it just stays like that.
It has to stay like that.
Does it need parentheses like that every time I'm doing it?
Hold on, let me try to find my calculator here. You don't. It's just negative sine of 3x. It just stays in there. So this is the sort of thing that has to be done with a calculator, unfortunately. You can set up the integral by hand, except the upper bound has to be found with a calculator. So I'm going to show you guys how to do this. This is the sort of thing that would be more likely on a bonus for us. In terms of, yeah, don't break the thing. You dropped it. Say again? Yeah. So option intersect, and then just enter twice or 3 times to get the intersection point.
Oh wait, can't you just use your calculator?
Yes, you have to.
Oh. Well, I was thinking like solve for it and then plug that in.
Oh, I see what you mean. So what is this? E to the negative x squared and negative sine of 3x. Also, make sure your calculator's in radians.
Oh, thank you for reminding me. I knew that.
So
When I get a negative number,
negative sine of 3x.
Oh, wait.
Yeah. Second trace.
E to the negative x squared.
How many numbers you lost around?
This is math class, so don't worry about significant figures. Negative x squared.
Well, yeah, we'll hold for it. So round to the decimal.
Negative sine of 3x. All right. Yes. So, first of all, in terms of setting up your integral, you need to know where do these two curves intersect. Instead of just graphing each curve individually, I set things up so that I'll be able to get the integral right away as well. So I subtracted the two curves from each other and said e to the negative x squared, because that was the top curve, minus negative sine of 3x, because that's the bottom curve. And to find where they intersect, I basically just set that equal to 0. And in the calculator, the way I solve that is trace 0 option, and I'm finding this first place where the graph hits x equals 0. So I do second 0 option, and then blinky dot a little bit to the left of the x-intercept, hit enter, blinky dot a little bit to the right of the x-intercept, hit enter, and then hit enter a third time. And so that's going to be my upper bound of integration. So now I'm going to say my integral is from 0 to that thing, 1.139, of e to the negative x squared minus negative sine of 3x dx. So then that's what I integrate. So I've already gotten this equation plugged into my calculator, and now I just do second trace integration. That's option 7. And I'm going to go from 0 up to 1.39. So 0, 1.139. And boom, there's your integral, 1.445. That's option B. So to save yourself a little bit of time with like having to like graph one thing with two curves and find where they intersect, and then graph again with the curves combined to do the integral, you can combine them right away as it's going to appear in the integral, and then instead of finding where these intersect, find where this thing hits a 0 with your trace button. As we get, towards the AP exam, once we're done the whole curriculum, we'll spend more time in the calculator and talk about how do you use your calculator to do this sort of stuff some more. So on your bonus problem, you'll have to be a little more fluid on the calculator. For the rest of the test, you can get by with doing things by hand and then just evaluating the integral that you set up. But this one's especially tough because you have to come up with the bound of integration and then evaluate the integral all with the calculator. Any comments on that thing?
When I do, because you have to do like second trace and 0, and then you enter.
Yeah.
Mine just says error.
Are you, so when you do second trace 0, you've got this blinky dot. You've got to move it a little bit to the left of the x-intercept that you're finding. Hit enter. And then move it to a little bit to the right of the x-intercept and hit enter. So you see how at the bottom it says left bound? So basically the calculator is doing the intermediate value theorem. You got to get an output on the left side, an output on the right side, and then hit enter a third time. So if you just go enter, 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 that's only for doing an intersection between two curves, but not for finding a 0. Any other questions? All right, so on your test next week, Tuesday, Wednesday, we'll do more of this review on Monday. There's going to be 10 problems plus a bonus. 5 are multiple choice, 5 are free response, I think. Let me check real quick. 1, 2, 3, 4, 5. Yeah, so 5 of each. And then there's 2 cross sections. Those will be obvious. They'll like reach out and slap you in the face and say, I'm a cross section. There's 3 areas, same thing. It'll say, find the area. And then there's 5 others that are washer, shells, and discs. And I won't tell you which ones they're which. You'll have to figure out, is this a washer or a shell or a disc situation? And this breakdown is a little wishy-washy because, as we've seen, there are certain things that can be done in either method. So I'm saying this is how I would do things, but if you want to do like a washer problem with shells, or what I considered a washer problem with shells, you can probably do that. And as long as it's not like one of the multiple choice options, which is got answer options forcing you in one direction, then if it's like on the free response part, and I think it's a washer, but I'm not telling you it's a washer, and you do it with shells, then you might think, oh, there were 3 shells problems and only 1 washer, for example. So this is like the breakdown doing it the way I do it, but that doesn't mean that you're going to have the same breakdown when you do it your way. Sam?
Can you tell us which ones are like multiple, like are like all the area ones multiple, or like
Nope. It's a mix.
you're not getting those? Are like both the cross section ones not multiple? With cross sections, it's not gonna really do anything. Washer shells, this. Well, like you're gonna include the washer shells and this are like one thing, like one. They're like a total 5 problems.
Yeah.
Just tell us which of the 5.
So you want to know which of these 5 are multiple choice and which are free response?
And then for
I can guarantee you that there's at least one area that's multiple choice. I think the disc is multiple choice, but I'm not willing to bet on that. And I think one of each of these is multiple choice, but again, I'm not entirely sure. And then there's another multiple choice that I'm not remembering which of these things it is. So, I mean, you'll find out on Tuesday.
I think you should just
And
like all
I'm going to give you the whole thing on Tuesday, and then you'll come back and finish it on Wednesday. So rather than try to figure out, like, back and forth, just here's the whole thing. You got 2 days to do it.
there's not really cheating for it, I don't think. I think you can just kind of study next week.
That's kind of what I felt like.
Yeah.
So that's going to be your test next week. And we'll review more on Monday, and you have the whole weekend to prepare, and you have loads of these problems with the areas packet and the volumes packet and the other worksheets I handed you. And I recommend you do them.